With embedded systems, security is a very important part. And these days, even with AI, you have to worry about things like the models. So you could tell us a little bit about Thistle and how you're taking these things into account and preventing people from doing bad things.
Yeah, well, in the devices space, we have kind of an underinvestment in security compared to general purpose operating systems. So there's a lot of things that we know how to do in the data center or on a workstation that hasn't made its way over to devices. And given how complex these systems are, how robust they are, how that we attach them to all the same networks with all the same exposure, and then we attach them to physical systems that have real-world impact. The security requirements for these kinds of devices just grow and grow, and we are seeing them being attacked more and more frequently. Just in the last week, we saw a Danish dam, like a valve being attacked, and the Canadian government released a report about a number of attacks, including a temperature control system for a grain silo, which could potentially cause the food to spoil, and for an oil refinery, another valve. So we're seeing these systems attacked. The impact of these kinds of attacks has real world significance, and so there's a real need to protect these systems. And so a lot of the mechanisms that are required to build that kind of security resilience, they're hard to do right and really easy to get wrong, right? So what Thistle Technology is trying to do is make it really easy for developers to incorporate these low-level security capabilities into their devices really quickly and easily.
Okay. Now, the one example you have here is taking a look at a camera reviewing an electrical system. Can you tell us what the demo is and why it's important?
So after you spend a huge amount of time and money and resources in developing your model, your AI model, and you deploy it to the edge, and then that device lives in the world somewhere out of your control, right? You want to make sure that your investment is protected. So there are two aspects. One is making sure that you are protecting the device, the model on the device, and also in transit, but also being able to verify that the model running on your device is the one that you intend. So there's this aspect of attestation, this validation, making sure that this is the model that should be deployed to the system. It's being able to be verified by hardware, so no one's able to sneak in something malicious or nefarious in its place.
Okay, so in this case, when it detects a fire, that's what you want. If you change the model, it could be very confused.
We want to make sure that we're actually detecting the fire and not convinced by a malicious actor to ignore something that really should be flagged.
Okay. Now, it's not just models that can be protected. Tell us about the other pieces that could be addressed with the solution.
Yeah, making sure that the system is running the software that you intended, and disallowing anything else from booting, right? So being able to sign the kernel and have the kernel verified before loading that the signature matches, so that you are sure that the code that executes the kernel is actually the code that is intended, and the system has a hardware root of trust that is able to verify this. And this is the start of your trusted execution chain. You can then say, okay, well, I'm going to restrict execution to only components that are likewise validated, and build on this over time. You can also use this to deploy secure configurations to make sure that the configurations in your deployment are signed by somebody in authority, right? So that the device doesn't just follow the instructions that just anyone sends it, that it's following the instructions that were intended and are able to be validated by the system all the way down to that hardware root of trust.
So from a developer standpoint, how do they incorporate these tools into their application?
Well, Thistle ships developer tools, libraries, and backend services to make it kind of a turnkey system. So you're able to get these capabilities in place without having to do very much in the way of engineering. We work with software manufacturers to support your board right off the bat. So for a lot of these boards, it comes with support already from the manufacturer. And between Secure Boot, which we have developer tools to either configure your bootloader, or you can leverage our bootloader. You can use our tools to partition your drive, so you've got a failover drive that allows you to recover in case you ship an update that doesn't work on, some edge case that you're not aware of, right? You want to be able to, first of all, come back up in a known good configuration, and then collect the information for what went wrong, so that you could ship another update eventually that fixes whatever that problem was, and over time get to this degree of reliability through iteration, because you're actually able to fix the problems instead of just losing those devices when an update doesn't doesn't allow them to come back up. These systems will come back up. And then having the firmware signing service means you don't have to stand up all of these online services to support your updates. So signing the firmware service, signing your firmware through the firmware signing service, and then deploying updates through the update service, so that in addition to guaranteeing the integrity of the kernel, updates over time are also signed, also validated,
Right.
and allow you to maintain that secure execution chain.
Excellent. Well, thank you for filling us in on Thistle's security solution.
Thank you very much.